This video will be some practice problems on related rates. So I would recommend you follow along, try the problem first yourself as it appears on screen, and then come back here to see what the solution is and how I thought through the problems if you got stuck, okay? Without further ado, let's go with number one. I believe there's four problems to this problem set, okay? So a particle moves along the path y equals x cubed minus 3x squared plus 2 if the particle's horizontal rate of change when x equals 4 is negative 3 feet per second. What is its vertical rate of change at that instant? Okay, so go ahead and try this on your own. This is how I always approach related rates. I start marking down in variables what I'm given and what I want to find. So, for example, they give that x is equal to 4, okay? And it says particle's horizontal rate of change is minus 3 feet per second. Horizontal rate of change, that should be a derivative. So this is horizontal rate of change. So that's if x is horizontal, y is vertical. Horizontal rate of change is dx dt. So dx dt is negative 3. Okay, and what do we want? It's asking for its vertical rate of change at that instance. So vertical rate of change, that is dy dt. Okay, so in order to get dy dt, we probably need an equation for y, which they give us. Okay, so let's just differentiate this. Dy dt is, we need to implicitly differentiate here, okay? Y is a function of x, but x is a function of t. So if we want to differentiate y with respect to t, we need the chain rule, essentially. Okay? Or you can just think implicit differentiation. Okay, so because y is changing with respect to time and x is changing with respect to time as well. Okay. So just think of it as implicit differentiation. And you could also think of it as chain rule as well, but I'm not going to go over that in detail here. So just implicitly differentiate. So dy dt is 3x squared dx dt minus 6x dx dt. Do we have all the pieces? Because we want dy dt. Do we have x? We do. Do we have dx dt? We also do. So plug everything in and you should get negative 72. Don't forget units though. For these related rates problems, you always need units, feet per second. On the AP exam, if this was a free response, if this were a free response question and you forgot your units, you would get marked off like a point or something like that. So don't forget your units. Okay. Number two, if a spherical balloon is being deflated at a rate of 5 inches cubed per second, at what rate is the radius of the balloon decreasing when the radius is 5 inches? So how do we go about this? So let's mark down what we're given. The spherical balloon is being deflated at a rate of 5 inches cubed per second. So this, if we just look at the units, inches cubed is the volume, inches cubed per second. This is the rate of change of the volume. So this is dv dt, if we call v the volume, okay? So specifically, dv dt is negative 5, not positive 5, negative 5. Why is it negative 5? It's being deflated at a rate of 5 inches cubed per second. So the volume is decreasing at a rate of 5 inches cubed per second, or we notate it as minus 5 inches cubed per second, okay? It's asking for rate, at what rate is the radius of the balloon decreasing? So if the radius is r, we're interested in dr dt. And we expect dr dt to be negative because it's asking at what rate it's decreasing. And they give us r equals 5. So that's what we're given. dv dt minus 5, r is 5. We want dr dt. So we probably want to use the equation for the volume of a sphere because we probably need to differentiate to use this dv dt, okay? So what's the equation for the volume of the sphere? You might be given this on the AP exam, I don't know, but this is easy enough to remember. Volume is 4/3 pi r cubed. So we differentiate this with respect to time, implicitly differentiate. So dv dt is 4 pi r squared dr dt. Do we have everything? We have dv dt. We have r. We want dr dt. So we plug everything in, solve for dr dt. You would get negative 1/20 pi. And don't forget your units. It's inches per second. The radius is in unit of inches. The time is in unit of seconds. Okay. And as I was saying, it makes sense that our dr dt should be negative because it's decreasing. Okay, so when the thing decreases, the derivative is negative, you remember, all right? Problem 3, a cube was dropped into a vat of nuclear waste, setting off a chain reaction of events that eventually caused the cube to possess superpowers, among them the ability to eat rocks. Strange problem, but okay. As the cube amassed these superpowers, it swelled at a rate of 7 inches per second. At what rate was the surface area of the cube changing when one of its sides was 2 feet long? So be careful with units. So go ahead and try this on your own. So what does this give us? It swelled at a rate of 7 inches per second. So this unit, inches, what is it describing? It's describing probably the length of one side of the cube. Okay? So if we call the side of the cube x, this is dx dt. And what is it asking for? At what rate was the surface area of the cube changing? So if the surface area is S, we're interested in ds dt, okay? And one of its sides is 2 feet long. So x, remember we call the x up here because this is dx dt. So x is 2 feet, which in inches is 24 inches, right? Okay, so that's what I wrote over here. We're given these things. We want ds dt. So since we want this, we probably need the equation for the surface area of a cube. What is that? Well, each side of the cube is a square. The area of a square is x squared if the side length is x. There's 6 faces on the cube, so it's 6x squared. If we don't remember the formula, that's how we think of it, okay? Differentiate because we want ds dt, right? So ds dt is 12x dx dt, okay? We plug in x, we plug in dx dt, we get ds dt, and that is 2016. Don't forget units, it's inches squared per second, okay? Number 4. During a performance, an actress displays her athletic prowess by skydiving out of a helicopter 100 feet away from a cliff. However, the chutes unfortunately fail and the actress plummets. If her position in feet is given by S of t as the sky, find the rate of change of the angle of depression in degrees per second at t equals 30.9 seconds for a viewer standing at the edge of the cliff, assuming that the viewer's head is 600 feet above the floor of the valley below. Lots of words, so go ahead and try this one. Okay, this one you for sure will need a calculator, I should say. Okay, so let's just sketch what's going on. Okay, so there's this viewer here, and there's the person plummeting. Okay, and it's asking for find the rate of change of the angle of depression. So this angle, if you remember what angle of depression is with respect to the horizontal there, looking downward, this is the angle of depression theta right there. Okay, so her position is given by this guy, okay? And this thing is 600 feet above the floor. This is 100. Do we need all these pieces of information though? We might. So, or some of it might be a distraction, to be honest. So let's take it piece by piece. Okay. So again, as I was saying, we want d theta dt because it's asking for rate of change of the angle of depression. Okay. So we want d theta dt. How can we get a relationship between, or how can we get theta in general, I guess? Okay. Well, this is a right triangle. So tangent theta is x over 100. Okay. If we call this distance x over here, the vertical distance between the viewer and the actress. Okay. So tangent theta is x over 100. Now we just differentiate because we want d theta dt. So implicitly differentiate secant squared theta d theta dt equals 1 over 100 dx dt. Okay, so we don't have all our pieces of information yet because we want d theta dt, but we need theta And we also need dx dt. So how do we find these two pieces? So this is the challenging problem of this problem set. I don't think you, I don't think this difficulty of problem will appear on the AP exam, to be honest. I haven't seen it in the multiple choice problems I've seen, nor free response questions. But of course, if you're able to do this, you should be set. But if you're totally stuck on this, I wouldn't worry about it too much, to be honest. Okay, but anyway, to get theta, we need to get x first. So this distance, so this is where the 600 comes in. So at time equals 0, the person is at exactly 600 feet. Okay. And then as time passes, that's the free fall equation that they gave us. This, if you know physics, this should look familiar. Minus 16t squared. This is the portion for like what's it? A solution due to gravity. Because if you differentiate, the solution is minus 32, right? So this is the free fall equation. So as time passes, it'll be 600 minus our s of t that they gave us, okay? So therefore, because we want to know the height at t equals 30.9, the height of that free falling person. Okay, so x of 30.9 is 600 minus s of 30.9. So this is where we need the calculator, put it in, by 63.04. So after 30.9 seconds, I think it was seconds, right? This person would have fallen some amounts, and she, I think was actress, right? She will be at 563.04 feet. Okay. So that now that we found x, we can find theta. So tangent theta is we found our x, that's 563.04 over the 100 still fixed. Okay, so theta, if we put it in our calculator, is 20.284 degrees. Okay, so we got a theta, but remember we also need dx dt. So we just differentiate our equation up here, our x of t. X prime of t, or dx dt, same thing, is minus s prime of t, which if we differentiate this, it's just minus 32t. Okay, so x prime of 30.9 is 988.8. So let's put everything back into this equation over here that we found earlier, because we were trying to get all the pieces. So we want d theta dt. We just found what theta is, so we can find secant squared theta. We found what dx dt is as well. So plug everything in, you start solving for d theta dt, you get 8.7 degrees per second. Okay, so the hard part about this is we got to set up the equations carefully, or you got to kind of picture what's going on first. That's honestly the first hurdle. Okay, so they're asking for d theta dt, but this x is not very typical as well. You start from 600 and then you start falling as time goes on, and then it's multiplied by that equation. So that part's not quite standard as well, but hopefully I explain why. All right, and then that models the position or the height of the actress. And then after that, the things are more straightforward, hopefully. Okay, again, if you're just totally lost in this problem, I would maybe recommend spending a few minutes to try to understand what's going on. If you're still totally lost, I would recommend just don't worry too much about it. For sure, you need to know these level problems, the problem 1, 2, and 3. These are much more standard, and you can for sure expect these types of problems on the AP exam. Problem 4, maybe not so much. Okay, hopefully this is helpful, and hopefully if we're totally stuck on these related rates problems, hopefully as I was thinking out loud, maybe you picked up something. All right, please give this video a like if you found it helpful in any way, and hopefully I'll see you in another video as well. Bye.